You ever hear about a curse that actually gets stronger the more you know? A paradox that haunts the very heart of AI and kind of messes with how we think about data itself? Well, today we're going to dive into one of the weirdest but most important concepts in all of data science.
Okay, think about this for a second. You'd assume more data, more features, more info. That's always a good thing, right? It's got to lead to smarter models, better decisions. But what if I told you that sometimes adding more can make things completely backfire? That it leads you straight into confusion, not clarity.
And this isn't some bug or a simple mistake in the code. No, this is a fundamental, totally unavoidable property of how data behaves in these really high dimensions. Understanding this is the key to unlocking how modern machine learning actually works. And it's why just having more data isn't always the answer.
All right, to really get our heads around this, first we need to talk about what dimensionality even means here. And get ready, because your intuition about basic things like space and distance, it's about to get turned completely upside down.
Now, don't worry, we're not talking about sci-fi dimensions or parallel universes. It's actually way simpler than that. Think of it like this. You've got a data set of houses, right? Well, the price is one dimension. The square footage, that's another dimension. The number of bedrooms, yep, that's a third dimension. Every single feature is its own dimension. So let's start really simple. If we only look at the price of houses, all of our data points just fall on a single line. That's one dimension. Super easy to picture. Okay, now let's add a second feature. Let's say square footage. All of a sudden, each house is a little point on a flat plane, like a scatter plot you draw on a piece of graph paper. That's two dimensions. Still makes total sense. So what happens when we add a third one, like number of bedrooms? Well, now our data points are floating around in a 3D space inside a cube. This is basically the world we live in, so we can still kind of visualize it. But this is where our intuition just hits a brick wall. What about something as simple as a tiny 100 by 100 pixel grayscale image? Well, each pixel's brightness level is a feature. That's 10,000 features, which means that one little image, it exists in a 10,000 dimensional space. I mean, just try to picture that for a second. Our brains literally can't do it. And this is exactly where things start to get really, really weird. And get this, we're not the first people to struggle with this idea. The term curse of dimensionality was actually coined way back in the 1960s. A mathematician named Richard Bellman came up with it to describe all the bizarre, counterintuitive problems that pop up when you start working in these vast, unimaginable spaces. So why do we call it a curse and not just, a quirk? Well, it's because in these high-dimensional spaces, the basic rules of geometry that we all take for granted just start to break down. And that has disastrous effects for our algorithms. To really feel the scale of this problem, check this out. Let's say 10 data points give you pretty good coverage on a single line, right? Well, to get that same density, that same level of coverage in just 10 dimensions, you wouldn't need 100 points or even 1,000. You would need 10 billion points. It's insane. So here's the crucial point. The volume of the space your data lives in just explodes exponentially every time you add a new feature. And your data points, it doesn't matter how many you have. They become incredibly sparse and isolated. Kinda like a few lonely stars in a vast, empty universe. This slide just lays it out perfectly. In low dimensions, over on the left, everything behaves like we expect. Data clumps together, you can see patterns, it makes sense. But then you look at the right, in high dimensions, and this bizarre thing happens. Every point becomes far away from every other point. The whole idea of a nearest neighbor becomes almost meaningless because, well, everyone is a distant neighbor. Okay, so space gets weird, things get far apart. So what? What's the actual real-world damage here? How does this mathematical curse actually break the machine learning models we're trying to build? Well, the number one enemy that the curse of dimensionality unleashes on us is a problem called overfitting.
And trust me, this thing is the silent killer of so many machine learning projects.
So, overfitting is what happens when a model has way too many features. It has too much freedom. And instead of learning the real underlying pattern in the data, it just memorizes the training data perfectly, including all the random noise and little quirks. It's like that student who aces the practice test because they memorize the answers, but then totally bombs the final exam because they can't handle a single new question.
Now, I know this sounds pretty bad, but here's the good news. For decades, data scientists have been battling this curse, and they've actually come up with a powerful set of tools to fight back and find the real meaning hiding in all that empty space. You've basically got three main strategies. First up is feature selection. This is kind of like packing for a trip. You can't bring your entire house, so you have to thoughtfully choose only the most essential items and leave the junk behind. Second, there's dimensionality reduction. This is more like creating a shadow of an object. You take a complex 3D thing and project it onto a 2D surface. Sure, you lose some of the fine detail, but you keep the essential shape. And third, we've got regularization. Think of this like putting training wheels on a bike. It adds rules and penalties to stop the model from getting too complex or too wild, forcing it to learn a more stable and general solution.
But beyond all the math and the algorithms, this whole strange phenomenon teaches us a really profound lesson about information and knowledge itself.
And this, right here, is the core takeaway. In our big quest for knowledge, just piling on more data, more variables, more features, it doesn't automatically get us to a place of clarity. In fact, a lot of the time, it just adds more noise and more confusion.
So the real art of machine learning, it turns out, isn't just about feeding a machine a mountain of data. It's the art of being sort of a cosmic map maker, navigating these impossibly huge, empty spaces to find the simple, elegant, and powerful patterns that are hiding deep inside. So as we all generate more data than ever before in human history, the curse of dimensionality leaves us with this really critical question. And it's not just for AI researchers, it's for all of us. How do we make sure we're not just collecting infinite features, but that we're actually finding the meaningful patterns that lead to real wisdom?